All right, it looks like folks are trickling in, but I'd like to get us kicked off. My name is Sarah LaBelle, and I'm the production manager here at Eckerson Group. And it is my pleasure to welcome you to today's webinar on avoiding the data swamp and having successful streaming data pipelines to the cloud. We are thrilled that you're able to join us for the event today. A little bit of housekeeping. Before we kick it off, if you have questions or comments, you can use the Q&A button at the bottom of your screen, and we'll be addressing them about partway through and as we go along from there. You can use the chat button if you have a problem or a question for the administrator. Those go to me, and I'll do my best to answer those types of questions. So without further ado, I'll introduce today's speakers. We're going to be hearing from Kevin Petrie, the Vice President of Research here at Eckerson Group. And Kevin has been in the industry for 25 years, deciphering what technology means to practitioners as an analyst, writer, instructor, marketer, and services leader. And from Equilum, we have Ido Friedman, their CTO. And he is a seasoned data professional with more than 15 years of production experience as a data architect, data engineer, and CTO. He has vast hands-on experience in numerous data technologies across many industries. So, Kevin, would you like to take it away?
All right. Thank you very much, Sarah. Really pleased to have the opportunity today to speak with you. What we're going to do, this will be conversational. We'll have some give and take with Ido and me as we walk through some of the trends that we see in the industry. The goal is really to define why organizations are moving to cloud data platforms, why you need streaming data pipelines in order to enable that shift and in order to drive your business on cloud, and then provide some guidelines about how to actually make that happen and do it successfully, because things get tricky very quickly with modern enterprises as they try to transfer their business and optimize their business on the cloud. The cloud offers many advantages, but simplicity is actually not one of them on a few different dimensions that we'll walk through. So there are three megatrends that we can start with. The first is digital transformation. I think we all agree that the rush to digitize business interactions continues at breakneck speed. COVID shock over the last 18 months continues to prompt enterprises to embrace telework, to digitize more of their interactions with customers. And there are just many ways in which a lot of the core aspects of business are now taking digital form. And the success of an enterprise really hinges on its ability to digitally transform. Modern analytics is an equally important megatrend. And as you've created all this, as you start to codify and capture in digital form all the digital business interactions, there's an increasingly compelling opportunity the enterprises have to analyze their data, to drive business decisions, and therefore make sharper, faster decisions. And so if we look at modern analytics, there are really two aspects to it. One is data democratization, helping more business-oriented decision makers build data and analytics into the decisions they're making, into their operational actions. And there's also the need for advanced analytics. This is where we get into data science. We get into real-time and predictive analytics to look around the corner, figure out what might not be immediately evident, and so that you can capitalize the increasingly perishable value of a business event as it happens. So modern analytics is a major source of investment for a lot of enterprises, and I'm sure a lot of folks on the call. Data modernization supports digital transformation and supports modern analytics and is getting equally important attention. Data modernization means you're trying to streamline and modernize, improve the efficiency and the effectiveness of the data architectures that can support your modern analytics, that can support your digitally transformed business. So those three megatrends, digital transformation, modern analytics, and data modernization, are really propelling enterprises, and this is true for folks on the call, I'm sure, to the cloud. So more incumbent, established Fortune 2000 companies are looking to become cloud-enabled. They're looking to become cloud-first, meaning the default assumption for a new initiative, a new operation, a new analytics initiative might well be to move it on the cloud, put it on the cloud first. There are also a host, as we know, of young companies, a lot of unicorns in the tech space and others that are cloud native. They're able to optimize on the cloud from the get-go because they don't have a lot of heritage architecture inherited from the 80s or the 90s. They got started in the last 5 years. They can start on the cloud. But all that's to say that organizations view cloud elastic platforms with elastic storage and elastic compute that you can consume in sort of a utility, pay by the drip fashion as a primary enable for innovation and competitive advantage. So cloud platforms require streaming data. And it's fair to view streaming data as oxygen, as lifeblood, water, choose your analogy, for cloud-driven businesses. And if you are optimizing on the cloud, you need to run your operations and also run analytics workloads on cloud platforms. And there's a real need for cloud agnosticism as well, because most organizations that are moving to the cloud have some on-prem infrastructure, but they're also favoring 2 cloud providers or potentially 3. A lot of folks embraced AWS and are now actively working with Azure and Google or Google as well, because they can optimize specific workloads on that secondary or tertiary cloud provider, because they might gain some type of negotiating leverage between the cloud providers. There are certain SLAs that might vary by cloud provider, by region. These are all forces that are really driving a multi-cloud scenario, and that creates the need for cloud agnostic operations and analytics that can run on one or more clouds in terms of your platforms. So this, again, is intending to help organizations innovate and achieve competitive advantage on the cloud. And the streaming data pipelines, or the streaming data, is going to come in from all kinds of sources. Legacy systems. Organizations often have mainframe, SAP, iSeries on-prem. Relational databases, Oracle, SQL Server, a lot of the usual suspects. ERP applications. Again, SAP is a primary example here. There's also a whole set of more advanced or newer data sources, SaaS applications, telemetry sensors that are helping drive all kinds of Internet of Things use cases to improve factory operations, supply chain efficiency, and so forth. And then clickstream data that'll give you all those fingerprints about what your organizations and the footprints, what your customers are doing as they visit your website, as an example. So this is just a tip of the iceberg in terms of the types of data that the cloud platforms are going to feed on. They're going to live and breathe this stuff. And cloud operations and analytics are going to rely on those data streams from a lot of different sources. So I'll pause here and see if Ido has thoughts, if he wants to chime in terms of experience in working with a lot of enterprises represented by folks on the call.
Absolutely. So I wanted to add sort of a bit of a weird point of the cloud allows you to make errors, and they're not too expensive. So I've seen in the data domain, I can give specific examples like data warehouses that have been used along the years and sort of have been developed in looking backwards from now, weird ways. And a lot of people have sort of signed very long contracts with different data warehouses or data solutions. And looking back, they said we should have used something else. So when you're in the cloud, you are easily allowed to make errors and choose other solutions. And again, if you look at streaming and the way you pull in data, you could easily push your data to more than one data warehouse and try out solutions rather than what you used to do on-prem where you bought something and you sort of had a very long-term marriage with it. So life is much easier in the cloud.
That's very well put. I spent 5 years with another vendor in this space, and that was a common theme with enterprises. They'll put their data and their workload on one platform, but they might well change that next year as they respond to this trial and error process of figuring out what works. And the ability to do that without stranding or your data center cabinets or having to buy new ones is a big deal for the cloud.
Absolutely. I've seen even just costs as a key aspect here. Some new data warehouse or data lake or data something pops up and it's a quarter of the cost of what you used. And that's an initiative to move. So there's many reasons.
Very cool. Okay, so let's get down to brass tacks a little bit more in terms of what these architectures look like. I'll build this out and, again, would love your thoughts. So AWS, Azure, and Google Cloud are the big three when it comes to cloud infrastructure as a service, providing decoupled storage and compute resources in order to support in a very elastic fashion different workloads, both operational and analytics. And the cloud platforms that rely on this are, on the one hand, cloud databases. There are a lot of cloud native databases or cloud dependent databases. MongoDB, MySQL, Postgres are some examples. MongoDB is particularly interesting because they're one of these companies that, like Cockroach and others, are leveraging highly distributed environments that are partitioning and replicating data across geographically distributed environments in order to take advantage of some cloud architecture benefits. So this is the operational side. These are the applications that maybe they're cloud native, maybe they're ported to the cloud, are going to run on cloud databases, relying on infrastructure from 1, 2, or even 3 cloud providers. And then the other side of the equation is the analytics workloads. This is where we get into a number of analytics platforms. Azure Synapse is becoming the new version of SQL data warehouse on the cloud, combining data lake and data warehouse architectures. And then there's the cloud native options. There's Databricks, there's Snowflake that are starting to bring together in a pretty interesting way data warehouse and data lake constructs, i.e. cloud native object storage that's elastic, so you get the efficiency and the economy benefits of data lake storage, but then familiar SQL data warehouse type structures on top. And so this is what, at a high level, those architectures are going to look like. And data pipelines need to stitch it all together, because it's rare that you have a set of operations that doesn't need data from somewhere else. And it's very rare that you have analytical workloads that don't need data from multiple sources. And so data pipelines need to bring that data in at increasingly low latency or increasingly in a real-time fashion. They need to bring in data from a lot of sources, send it to a lot of targets. A lot of different data types are involved here, and they do it to support an increasingly diverse and high volume set of users and tools. So you can envision just how complex the set of pipelines can become in order to support that type of ecosystem, that type of cloud-driven ecosystem. So these complex data platforms or complex data environments require fast and efficient data pipelines. And so we'll spend the rest of the webinar unpacking what that means, what streaming data pipelines are, and how you might approach architecting those using tools. Any thoughts on this?
I do strongly want to emphasize on moving between clouds. Even us ourselves internally, we've moved 3 clouds in the last few years, and there still might be moves in the future. So usually in the past, choosing a cloud was sort of a lengthy operation, a lot of analysis, and once you chose it, you sort of stick to it. A lot of users used to use a lot of the built-in services, sort of like Redshift and others that are Redshift in Amazon, of course, and others that are a part of that cloud. And I think in the last few years, you can definitely see cross-cloud adoption, like Databricks and Snowflake that you have in this slide. Both of them support all the clouds, all the major ones, and definitely shows that people would like to sort of work with the vendor rather than the infrastructure for many use cases, especially in the data area. So it is very interesting to see the movement around there.
Yeah, it's great stuff. And it's funny because a lot of enterprise projects are seeking to consolidate data. There's an enterprise push for data consolidation onto, say, ideally one analytical platform that could support both BI and data science. Databricks and Snowflake are some options there, or Vertica as well. But the reality is that you want to move your data from 10 or more sources onto that. But next year, to the point we made earlier, you might well change your target. And there's always going to be one separate workload that you want to optimize elsewhere. So these data consolidation efforts over time really become data distribution in a different form. And that just underscores the need, streaming data pipelines in particular. So what is the streaming data pipeline? I'll build this out a little bit. You've got operational data sources of all types, telemetry sensors, clickstream, logs that are capturing digital events on IT infrastructure, and then the more traditional mainframe systems, ERP applications, and databases. All that data needs to be ingested, perhaps extracted, more often captured in sort of an incremental, discrete basis, and then streamed to your target. And along the way, oftentimes organizations need to filter that data. They might combine or join different data sets. They might need to reformat it so that it can be usable on the target, apply a schema to it, and they also want to cleanse it. So all these are examples of transformational tasks that can take place within a streaming data pipeline. And then the data is going to be delivered. It could be loaded, in which case it's simply being added to what's there. You could append data so that you're not changing what's on the source, so you could merge it. For example, handling inserts, updates, and deletes, and we'll talk about that shortly, where you're starting combining and reconciling record changes within tabular set of data on the target. And this is all the activities that can be required, one or more of them, as you ingest, transform, and deliver to an analytics target or to an operational target. I'll also add that you could well have transformation taking place on the target. I'd recommend looking for a data integration tool, a streaming data pipeline tool that could support the transformation of data in flight. That helps with efficiency in some cases, compared with transformation on the target. But the reality is that you're going to have both types of scenarios in a lot of organizations. And all this is taking place on premises, in hybrid environments, in cloud environments, multi-cloud. And we're talking about not just data, but also schema, source structures that might well change. You need to handle that schema evolution and register it. If the schema evolves on the source, you want to register that on the target in a very real-time fashion, and handling metadata that describes the data and describes the schema. So the pipelines themselves need to be configured. You want to have the ability to explore your data sources, figure what you're going to send to the target, configure these ingestion, transformation, and delivery tasks to send the data from source to target, execute that, and then monitor KPIs, latency, throughput, issues, things like that, and start to orchestrate all these pipelines, because there are lots of them, as we said before. So there's a lot goes into a streaming data pipeline, and you can see that it really is important to, as you ingest, transform, and deliver data on a real-time basis, figure out the right type of tool that can help streamline and simplify all these tasks. Ido, any thoughts?
Well, I would like to add one more word to this, which is automation. We've seen a lot of automation going in we see orchestration at the top there, but a lot of times I've seen deep word orchestration being sort of changed to full automation, even to the level of CI/CD on the data pipelines themselves. We'll touch a bit of that further down the line, but it's definitely something I've seen. Sort of the data engineers are going into the CI/CD domain very recently and very intensively.
Makes a lot of sense. And CI/CD is one of the four really pillars of data ops, so that you can continuously develop and integrate modular adjustments to the pipelines. Agree completely. And so change data capture, not a new technology, but still highly strategic to make this happen. Because what you're doing is integrating the data, taking it from the source, potentially transforming it, delivering it to the target in real-time increments. And so on the next slide, I'll talk about what that means and why CDC is such a fundamental building block to a streaming data pipeline. Okay, so to rewind slightly, traditional batch pipelines for decades would, on an hourly, nightly, maybe weekly basis, take structured data from a source database, from a legacy system. It would make a nightly copy. It extracts that data, that copy, run it through a server, and then they process both, whatever's changed in the last 24 hours, whatever the last window is, and the old stuff. So they're processing everything, and they're loading it to a target. Traditional ETL. It can be quite inefficient because you're reprocessing unchanged data every single time, which ties up processing power, it ties up bandwidth, it can interfere with production workloads, and it can cost a lot of money, and it's slow because you're almost always out of sync with the real-time changes that are happening in your business. So streaming data pipelines enable you to get past that, because what you're doing now is you're streaming data, you're extracting updates as they happen on a real-time basis. Real-time is a relative term. It might mean milliseconds, it might mean seconds or minutes, but it's fast enough to capture the business value of an opportunity, of a business event when it happens. So the streaming data pipeline can look into that source, it can extract the real-time change, and it's going to process just that change, just that update, and load it to the target, whether it's a database or an analytics platform. Change data capture can enable the streaming data pipeline, because what you're doing here is identifying the real-time incremental change, which can take a few different forms. It could be a row, a record that gets inserted into a source database. It could be an update to a row, to a record. Maybe a customer changed their phone number. It could be that you're deleting a record. Maybe the customer said, I have the right to be forgotten, so please take me out of your records. Or a schema change, which means you added a column, an additional field to track what your customer records are. These are just examples. So you're going to extract that insert, update, delete, schema change. You're going to send it to, you're going to process just that insert, update, and delete, and you're going to register on the target. So that might well be that you've changed record 2, you've added record 3, you've deleted record 4. Now, CDC extraction methods become important because you can do it a few different ways, and I'll work from the bottom up. You can do it with a query where you're continuously or very frequently scanning your source database in order to identify whatever's changed. That imposes an operational burden on your source. It can work, but it potentially might slow down your operations on the source. You could also have triggers, which are going to, every time there's a change on the source, it's going to trigger an update to a shadow table that takes up space and processing workload on the source system. Or you could do it with a log. And so a log-based CDC has the least burden on the source, because what you're doing here is you are scanning backup and recovery logs. In most databases, every time there's a source operational change, there's going to be the change, and that change is going to be recorded in the backup and recovery log that's actually separate from the production workload on the source database. So if you can identify within the logs your change, you can get that non-disruptively and send it to your target. And so the method of CDC is going to vary in terms of what's possible by source type. But in a lot of cases, the more you can do log-based CDC, the less you're going to impose a burden on that source. So change data capture is really the way that you can start to optimize these streaming data pipelines. And so, Ido, you've lived and breathed this stuff for many years. Would welcome any thoughts on what I walked through here architecturally.
I've got two thoughts here. First of all, I think that the arrows at the left show batch to streaming to CDC, which I see as another streaming sort of source. And it really sort of, defines the move in the world today that everybody wants to go streaming. And I think the main difference today, if you look like 5 or 10 years back, everybody wanted to go streaming even 10 years ago, but nobody really dared to go there because it was way too hard and way too complex. And I really feel in the last few years that things are getting easier. It is still very hard to do CDC, and you need to be very concentrated on that. But today you can definitely aim at that. And I think a few years back, it was something that everybody sort of dreamed about, but never did in the way that it's being done. And by saying the way is, I've seen today click streams being joined by ERP data from CDC, which is something I wouldn't dream about 10 years ago. It was sort of two domains. And today, because streaming is so widely adopted, you can actually do that. You can actually dream of something like that. Sort of IoT plus ERP works. We definitely see the move to there.
That's very cool.
Yeah, definitely.
Go ahead.
And one more aspect, I think that one of the challenges of batch to streaming, and I put CDC again as part of it, is sort of a change of how you think about data. How do you look at it, and how do you manage your aggregations or changes in the data? And I think that the world has adopted to that way of thinking. My data is moving, it's not static anymore. Everything needs to move. And I think even the business part of data, the business users are not willing to accept any excuses anymore. So they want the last transaction to be available in the report the same as the transaction that happened 10 years ago. Doesn't matter. It's the same for them. So I definitely think the world has matured into that.
So it's very cool. And I'll just build on that by underscoring the point that a few years ago, a lot of folks didn't necessarily need real-time data, but they were really tired of paying the compute costs, especially if it was on the cloud, of repeatedly processing unchanged data. So there was a cost benefit to getting to real time, even if you didn't need to consume the real time data yet. But now, then businesses are increasingly really needing that real time data in order to make real time decisions because of the mega trends that we talked about before. So there's both the cost benefit and the business benefit in terms of upside of having that data on a real time basis. Okay, so this is easier said than done. The challenges are data engineers are a perpetually overworked bunch, very talented. They know how to handle command line scripting, and there's lots of it that can be required using traditional methods and tools. Some feel wedded to SQL scripting and so forth. Others would certainly be very interested in reducing what they do there, especially when it comes to repetitive commands, through automation so that they can start to focus on more innovative tasks and just start to handle the sheer volume of sources, targets, users, tools, data types, and volumes and varieties of data, all of which are rising. So data engineers are looking for productivity tools. They're looking for automation. They're also looking for guidance. So if you can have a tool that'll start to give you pretty explicit instructions or default recommendations based on pre-populated commands, that really starts to help. That starts to help accelerate what they're doing. Performance bottlenecks are another significant challenge with enterprises because as you start to have data volumes go up, you're supporting more consumers, you're supporting more pipelines, you can have bottlenecks, reductions in throughput and efficiency. And so having a reliable ability to meet those SLAs for throughput and latency becomes increasingly critical as IT and the data engineers are working with the business. Data silos are obviously something we talked about before. It's kind of a mirage to say all the data silos will go away, but there is a need to combine previously siloed bits of data. I loved your example of talking about ERP data and clickstream data. There are a lot of different customer 360 examples that can make a lot of benefits, that could make a lot of hay in terms of driving business advantage by combining those previously siloed data sets. So that means the requirement from a data pipeline tool perspective is having the ability to integrate a lot of heterogeneous endpoints and heterogeneous data types. And so, the bottom line is that enterprises need to efficiently feed the high volumes, varieties, and velocities of data to cloud platforms. Okay. Any thoughts, Ido, or should we go to the next slide? Please.
Just one thought on overwhelmed data engineers. I think a lot of times underrated. It is definitely very hard to find resource, data engineers in general, data experts. And we've seen along the years in my current job and previous ones, I've seen a lot of DIY projects around the big data world that sort of, I think if you would try to quantify the success factor of them, I'm not happy to say that it's probably over 70% of those projects fail at some level. And the reason is that a lot of people have to do a lot of the same in different tools, in different aspects, different types of solutions, everything changing around you all the time. So people are rewriting everything every 2 years or something like that. And I think that the data engineers are coming to be a very important point in the organization. And I think if you try to better utilize their resources rather than writing the same code over and over, I think one excellent example is monitoring. There is no data engineer in the world who haven't spent like 50% of their job trying to monitor something they did. And everybody is writing monitoring scripts, monitoring frameworks, metric solutions, and whatever solution there is out there. And eventually you see very similar solutions being written by a lot of people and ending up 50% going to the dump and 50% sort of succeeding in some manner. So I think the resources there need a lot of channeling, I would say.
Yeah, AI and ML adoption in particular seems to fuel the need for data engineering efficiency because those data engineers are now being called upon to directly assist data scientists as data scientists figure out how to define features within ingested data sets, and also with ML engineers who are trying to figure out how to productionalize models within production data workflows. So data engineers are trying to learn new things and trying to help the innovation. And the more they can automate some of the basic stuff, the better, to help those new data science initiatives.
We've actually had conversations, by the way, with data scientists that they themselves said we are doing 80% data engineering and architecture. And then when there's time left, we do a bit of science.
Yeah, it is interesting that the data scientists have that kind of job description, because it's not what they're looking for, or the business is looking for. So use cases, there are lots of them. I've got a few categories here, and the one use case for a streaming data pipeline is a cloud migration, taking a data set, a workload, or lots of them from an on-prem or hybrid environment or source cloud and moving it to Cloud B. So that needs to happen. Streaming data pipelines can help, and CDC in particular, because then you can do a zero downtime migration. You have the bulk transfer of all the old data, but you can capture the real-time updates during the transfer. And by the time you point your application to the cloud target, you're in sync because you've captured all the real-time updates. Streaming data pipelines and CDC are critical for those cloud migration use cases. There's a whole set of business intelligence use cases, traditional dashboarding and reporting. There's an expectation increasingly for dashboards that they be based on real-time data. And then, log analytics is a big area. Observability is a big enabler for DevOps engineers, cloud ops engineers, IT ops engineers. I view cloud ops as kind of a combination of DevOps and IT ops, but all of them need to look at millions or billions of logs that capture what's happening on their infrastructure, and they can bring it together, analyze it. That's another use case. So embedded analytics starts to merge analytics with operational workloads. And we're seeing more and more of that, because you're not just driving smart decisions, you're driving smart actions. IoT maintenance, preventive maintenance, factory optimization are all critical ways to take advantage of real-time data, as is security analytics. Identifying anomalies, pattern breaks, and so forth can help you stop bad guys faster. And data science is obviously something that's starting to stitch into all the other use cases, where you've got data scientists cooking up advanced models, or even downloading a basic model from an open source library, training it on your data, and putting it into a production work stream in order to process real-time data. So fraud detection, customer recommendations, recommended home prices for real estate agents. There are just a ton of data science applications that could take advantage of real-time data flows. And streaming data pipelines are obviously driving all this. So I'll pause here, Ido, and see if you have thoughts. Obviously, I'm assuming you have customers that fall in many or all of these categories.
Yeah, absolutely. We have a very interesting use case we've seen in, I would say, 2 or 3 years around data scientists and BI/data engineers sort of trying to solve very similar problems with very similar tools. I think Jupyter is an interesting tool that has been used by the data science world, and it's sort of migrated a bit. It's widening. I've seen DevOps using Jupyter. And I think the sort of two use cases, the two sort of techniques are combining and touching each other. And I've seen a lot of interest from data scientists touching into data integration tools, and a lot of interest from the BI and data engineers touching into the data science tools. So I think there's a very interesting area there of what's going to be the tooling, the next level of tooling between these two.
Great stuff. Yeah, I agree completely. And it's pretty interesting to see the robust ecosystem of data science tools and scripts that are getting involved there. Okay, so if we get down to where the rubber meets the road, there are a lot of tools that can help you manage all this. And I don't want to go into too much detail, because I want to make sure there's time for Q&A and discussion, but I think there are 5 buckets that we recommend as product evaluation criteria. And we're working on a white paper with a Qualym, or for Qualym, to explore this in more detail, give you sort of a vendor neutral guide on how you choose the right streaming data pipeline tool. Obviously, you need to define with the business your SLAs when it comes to throughput, latency, and availability, and understand how well a given data streaming pipeline tool can enable you to meet those requirements both today and for future workloads. And you want to understand the mechanisms by which, to get to the second point here, those tools help you scale out compute, scale to support more users, more sources, more targets, more data types. A lot of pipelines now can leverage elastic cloud compute, which is great. You also want to make sure that you're aware of the cost implications of automatically scaling that cloud compute. So you want to get the right visibility into the methods by which your streaming data pipeline is going to scale out. Ease of use, big requirement, and not a new concept, but increasingly important given all the complexity we've described here today. If you can have a graphical interface that eliminates the need for coding for most or all of what you do, fantastic. Default commands based on prior history, and also look at the training that's required. You might have a very easy tool, but if you need to spend a lot of time learning it rather than continuing to use your other tool, that's an implication on the overall ease of use benefit for year one. Heterogeneous support is critical for multiple data types, data formats, sources, and targets. And Ido brought into the mix, Jupyter notebooks. There's a whole ecosystem of programming languages, of data science tools, of models that might need to be applied to a inline streaming transformation. And you want to make sure that what you're doing with your streaming pipelines remains openly interoperable with all that, with commercially available tools and with the really robust set of open source capabilities. And you want the flexibility to easily reconfigure, reuse, and integrate different data pipelines because there are going to be lots of them in your environment. And so I encourage folks to look for a streaming data pipeline product or platform that's going to help. It's going to be elegant to the degree you can and reduce some of this architectural and operational complexity. Ido, why don't I invite your thoughts here? And then I'll hand over to you for the next couple slides.
I'd like to add just one note here is if you look at sort of modern data pipelines, though the tools that are required around it, you might find yourself with quite a few vendors for one pipeline. So consider that as well, sort of 5 solutions or 5 products inside one pipeline might require a lot of orchestration between different products, different vendors. So that's definitely a part of complexity as I see it.
Makes complete sense. Good. Okay. So I think, Sarah, do we have questions that we want to address? And then I can hand over to Ido here.
Sure. We had a question come in from SK who asks, in the absence of a cloud data strategy in my company, what suggestions do you have to stream data more near real time into a DW platform, such as Exadata Oracle platform via a data lake conduit?
Great question. And I'm happy to go first. I think a lot of the principles that we're talking about here apply equally to on-prem targets. There's obviously an on-prem target doesn't have the same elasticity benefits, but in a lot of cases, it does have an equal need for real-time data because the business wants to take real-time decisions or actions. And also especially because you're paying for the servers and the other equipment that's going to process that data, there's a real cost and efficiency benefit to streaming as opposed to repeated batch ETL. So I think a lot of this is equally applicable. You want a flexible tool that can meet your requirements today and in the future. So the more you can standardize on something that can get you to the cloud in the future, when and if a company makes that decision, the better.
I think cloud agnostic should incorporate your own data center inside it. So it's not only cloud agnostic, it's data center agnostic. Doesn't matter what the infrastructure is, the tool should work on cloud or on-prem. And yeah, definitely we see a lot of customers still using data platforms on-prem because of costs or other aspects, and definitely still relevant.
Excellent. There are other questions, or should we proceed to Ido's section?
Yep, we just had one come into the Q&A from Allah, who is asking a cybersecurity type question, talking about migrating sensitive data and deploying telemetry sensors, IIoT, OT applications into public clouds pose cybersecurity risks, specifically with the emergence of quantum computing and hacking techniques that compromise the integrity of data in use and algorithms. How much can this risk be mitigated nowadays through confidential computing and quantum safe encryption?
It's a great question. And I think with a lot of technologies that are independent of streaming data pipelines, Ido, perhaps you have thoughts on what you've seen with customers. Are they looking for real-time masking, or filtering can help remove PII from a stream?
Yeah, absolutely. So I think there's actually two aspects to look at it. First of all, the word public is not as public as it sounds. You can be on a public cloud, but very privately. So I've seen a lot of organizations look at the public cloud as the extension of their organization data center. And they basically say, we want to be in the cloud and benefit from all the big things in the cloud, but we don't want to be public at all. We don't want to be exposed to the public domain. So no public IPs, everything is VPN, and everything is super secured. So we've seen a lot of those, and it basically sort of reduces the level of risk, and the only interaction and changes between a public cloud to your own data center, which is, by the way, usually hosted in the same physical areas, is who is the provider of the hardware. So public is not really public. It depends on how you configure it. You can get very private in public. And I think secondly, there's definitely a trust no one approach we've seen in the last few years of nobody can trust, even your own admin is not trustworthy. And people are definitely looking to mask everything, any data, including inside the data tool, including encryption and everything around it. And yeah, it is definitely possible, harder, and you might pay more CPU and other resources, but it's definitely possible. I would not think about not going to the public cloud because of it. I would definitely see that as another challenge on the way.
Great points. Agree completely. I mean, I think role-based access controls should be viewed as table stakes for any type of technology, especially streaming data pipeline tools, to help restrict by role what folks are doing with the data and with the pipelines they're using to manage them.
And even to the level of, we actually have seen a lot of multi-tenancy inside our product and requests for that inside a department and inside the same organization. So people want to separate, not necessarily from hackers, but internally. So definitely very interesting. RBAC and tenancy is interesting.
Excellent. Okay, so Ido, why don't you have two slides and we can put that up here and let you, I'll hand the baton to you.
Sure, excellent. So in Eckerson, we have a solution aimed at CDC and data pipelining data from anywhere to anywhere. Basically, cloud, of course, is a very, very common use case. But as you can see from the slide here, we handle many sources. You can see the same on our targets. The main focus for us today is CDC as a means of looking at your sort of legacy data as how do I make it streaming. And we've invested in Eckerson a lot of time on making CDC productionized and to the level of the common big data solutions. So we've developed our CDC integrations and incorporated into our big data system, which means you can sort of mitigate between the old world and the new world of, I want to benefit from big data products like Spark and Kafka, but I still have data in my Oracle or Postgres and SQL Server. It used to be sort of very different areas. Nobody used to combine these two, and we have definitely managed to do that. We are using Kafka and Spark internally, and we are consuming data from CDC with different sources, different techniques for each of them, which is, I think, still the hard part of CDC. You have to work around every source you touch, has different mechanisms to get the CDC to be efficient as you would like and to not harm your source. So definitely combining CDC with benefits of a data platform, modern data platform using big data tools is a key aspect, but still look at your capabilities around CDC. I think we don't have Oracle here, but Oracle is a very good example. There's like 10 ways you can consume CDC data from Oracle. Probably 9 of them is not what you want. So CDC is a very wide world, and you should definitely look at what you're gaining out of it, how much load you're putting on your source, can it do schema evolution, and other aspects that sort of seem as melt into that big CDC world, but there's a lot of aspects there and a lot of work that needs to be done there. One more important aspect of CDC is exactly one semantics, very much ignored in the big data world. I wouldn't say ignored, but it's sort of at the edges. Visual and sort of the initial big data platforms used to aim at 99% success, which is a lot of times okay. But when you put in CDC in the mix, it means you're going to get ERP data and you're going to get CRM data and a lot of business related data into your big data platform. That changes everything. You need to be 100% right. You need to not duplicate, not lose data and the whole thing. So definitely a very important point of sort of modern CDC framework.
Fantastic.
So that's a bit of an intro on what we've done in Equalum. The solution itself has been built around the concept of the open source world has achieved a level of maturity that is good enough for the enterprise on the surface. But when you go and dig a bit deeper, you actually find that enterprises want something different than what the usual open source product aim at. And as I said before, exactly one semantics is a very, very good example of it. Big data platforms don't aim at 100%, but in the enterprise, you want that. And the goal of Equalum was to stitch a solution based on the benefits you get from the open source world like Spark and Kafka, and get that ready to the enterprise world, which means I want to get everything monitored. I want to get my data exactly once. Don't duplicate it. Don't miss anything. I want to connect to my Oracle, but I also have Kafka. I also have S3, and I want to join them. I want to join them streaming. I want to enrich my data while it's being ingested. And the whole thing should simply operate. I don't want to touch everything. And a lot of people say, I want to have Kafka and Spark until they have them, because when you touch them, you understand the complexity of them. And in Equalum, we've actually taken all of that and said, we need to provide one platform, not something that can be sort of building blocks that can be stitched into a solution. We want to provide the solution. So I touched a bit about different vendors or the plethora of vendors, and we've seen that a lot. You have one vendor doing the big data world, one vendor doing CDC, one vendor doing monitoring, another vendor doing other aspects of orchestration, and you find yourself with a big data platform that does CDC, but you have 5 companies working with you. So besides the funding of all of that, you've got a lot of complexity and a lot of finger pointing of who's to blame. And we've tried to mitigate the whole thing. And we're basically providing one platform, including everything you would find in the common solutions that organizations use to stitch themselves. Again, monitoring, management, orchestration, alerting, as well as batch and CDC inside one system is definitely our aim. So that's what we have currently. A bit of our future, you can see at the top of the slide there, the word autonomous, which is very commonly spoken in our offices these days. We definitely see the data engineer as sort of the weak link in today's work. It's not weak because it's weak. It's very hard to find these guys. They're so good. They are hard to maintain and find. And one of the key benefits we're aiming at providing very soon is get autonomous things happening on your data. So if you want to get data ingested, we can look at the data and suggest things for you. Don't need to investigate. Another very interesting area around there is the work of data science and data engineers. The data scientist wants something, the data engineer might not even understand what to do. So they want to work together, and creating models autonomously can free up the data scientist from data engineering. So there's a lot of areas around making the pipeline autonomous, making the system autonomous and ready for the big world that we're working on currently. And I think that's the future of data pipelines. And I think it's a very interesting future for this area. I think everything's going to change, and hopefully to the best.
Very cool. So I have a few questions I could put to Ido, but Sarah, do we have other questions? I see some things on Q&A and chat here.
Yep, it looks like we do have some questions. Some folks had to join late and wanted to know whether there will be a recording available. That I can answer. Yes, if you have registered for the webinar, you'll get a follow-up email from us with a link to the recording and the slide deck as well. So that I can answer. And if anyone else has any other questions, you want to squeeze them into that Q&A box, we'll get to them.
I see one question from Allah. I think it's a response to what we said before around how do you get to the cloud and is it safe? And I must say, I've seen that question about 10 years ago, maybe a bit more when I first got into cloud deployments around, do you trust those vendors? And I must say that looking back, I've seen that these vendors, the big cloud vendors, have a lot more scrutiny than probably your current hardware vendor, or not necessarily hardware, but your data center vendor. So they have to comply with a lot more work and have to do a lot more to get their certification. So I definitely think that cloud vendors today better to host data and services than smaller data centers. Not necessarily what it used to be.
Yeah, agree. And it is interesting to rewind 6-8 years and see how conventional wisdom about the security risks has evolved, and people are increasingly embracing the cloud and viewing it as either maintaining or potentially increasing the security of their assets. So that's great. So do we have other questions from the audience?
I'm not seeing any currently, so I guess you should ask your question, Kevin.
Okay. So, Ido, final question. We've done work with Equalum on this. It's how much do you see organizations really looking to transform their data in flight as opposed to after it arrives at a target? Meaning ETL as opposed to ELT when you're talking about streaming data. You've got some capabilities to optimize the transformation of data in flight, in memory. Are a lot of companies taking advantage of that? Are they doing it more or less than transforming on the target?
I definitely see the move to there. It's sort of an approach you need to adopt. And it is, I mean, I can certainly say I've seen one key aspect that people are looking to do that, which is usually your target is very expensive to do transformations on. So it's not necessarily aimed at doing transformations. A lot of times your data lake, data warehouse is more aimed at providing fast reporting, fast aggregations, and not necessarily going to the row level. And a lot of times when you do transformations, you want to go to that row level and enrich your data row by row rather than aggregate. So I definitely see a lot of organizations touched just based on that. They want to reduce the load they have and the costs they have on their data warehouse. Doesn't matter the data warehouse because it's even on-prem. We've seen organizations with Teradata saying the same. It costs them a lot of money to have those CPUs, and it doesn't do that as well as you would do it row by row. So I definitely see that, but you need to adopt that approach. It means that your logic is in the flow rather than in your data warehouse. It's a bit of a change, but definitely going there.
Yeah, and that's interesting. And it's, I'm sure, driven, like you said, about the cost of compute, because the cost of cloud compute, that's where AWS and its ilk are making some money. Yeah. And it's where there's a real sticker shock at the end of the month with a lot of enterprises. The cost of cloud compute they didn't bank on.
Yeah, absolutely.
Okay, well, Sarah, why don't I hand over to you? Really enjoyed this discussion, and thank you, Ala and others on the line for some great questions.
All right, I think that's it for today, and we're at 11:30. So thank you so much for joining us, and hopefully we will see you at our next webinar, and have a fantastic rest of your day.
Okay, thank you, everyone. Thank you, Ido.